Well, good morning to everyone. This presentation will be a little different from the previous one. And my presentation is about the sustainable water reuse in the specific case of rural areas and small settlements. Introducing a good line to remark some question. The access to drinking water, the proper sanitation, treatment of urban wastewater, and a safe water reuse provide the backbone of development in a country. But there is an important imbalance between developed and developing countries or areas. The problem is more or less solved in large and medium cities or areas with adequate social, economic, and technological development. But unfortunately, the population most affected is concentrated on rural and scattered areas, are in surrounding in the large cities in underprivileged countries. If we analyze in detail this situation, for example, in the large urban communities of developing countries, we have a high coverage in sanitation and hygiene. This is very important. Availability of infrastructure for wastewater treatment and water reuse, water reclamation. Good quality in water research, water pollution issues, primarily concerned with amenity values and toxic substances. If we analyze the risk for the health related with the pathogens in this kind of wastewater, there is a predominance of virus if we relate with other pathogens. And it's very important the policies defined and enforced. If we analyze the Odent situation, small rural communities and developing countries, we have an additional problem. It's the water scarcity that limits by a serious way the food production. Not or inadequate sanitation and or wastewater treatment plants and wastewater reclamation plants. Quality degradation in water resource risk that produce a risk for public health. And when we analyze the pathogen situation, there is a high prevalence and persistence of intestinal elements, intestinal worms. And they have the presence of virus, bacteria, protozoan, etc. And there is a problem, is the difficulty to ascribe the cause due to high background levels. Related with the policies, these are not defined and enforced. Also, there are some countries that are making a considerable effort to reverse this situation. In the frame of water reuse, I would like to remark the forecast on water research. If we analyze the prediction for the future in water research, there is the prediction that in the year 2050, approximately 54 countries will be affected by water scarcity and water stress. So in this context, more and more countries are including the water reuse as an additional water research. For example, in this graphic, you can see that there are some countries, for example, emerging countries as China or Mexico, or for example, India, that are including the water reuse in their water resource management plan. There are very typical countries that are working in water reuse, for example, the United States, Australia. Well, here in this graphic, it does include Israel or Tunisia, etc., etc. And in Spain, we are working a lot in this additional resource, principally in the Mediterranean area. This is an important point. Okay, which technology options we have for the wastewater treatment in small communities? First, I would like to introduce a consideration about the characteristics of the wastewater in this kind of agglomerations. This agglomeration presents a high community dispersion, and this produces a complexity in infrastructure management. This is a problem when you have to design and implement a wastewater treatment plan in this kind of small communities. relate with the characteristics of the wastewater. This wastewater presents high oscillations in flow rate during the day, and this is other point to take into account. For example, in this graphic you can see that lower is the size of the population, higher is the flow rate during the day. Relate with the characteristics of this kind of wastewater, yes. In these small settlements is produced a small flow, but is very, very polluted. So which kind of technology we can propose? When we are in the frame of small communities, we can work with two kinds of technologies. Intensive technologies, as you know, extended aeration, etc., and the other extensive or non-conventional technologies. Which is the principal difference between this kind of technologies? The difference is really in the high energy consumption and in the implementation surface. For example, the intensive technologies and extended aeration present a high energy consumption. It's a negative point, but have a very positive point, low implementation surface. In the case of extensive technology, they need low or zero energy consumption, but they have a very negative point, that is the high implementation surface. So, most exacting wastewater treatment technologies are applied to small settlements. Okay, although some will be more adequate or appropriate than others. But really, we learn this sentence. Really, do we really learn from our mistakes? No. Not only in Spain, in all over the world, commonly in small settlements, have been implemented technologies with high treatment cost. For example, you implemented, I don't know, extended aeration, and for disinfection you can implement it an ultraviolet disinfection. Okay, this is a possible option. What is the problem? The problem is that the settlement cannot, or is impossible that they can afford this cost. So the result is an operative facility with severe operation problems. Here you have some pictures that I think is very common in all over the world. So which are the most sustainable technologies in the frame of wastewater treatment? Well, we have to look for technologies that follow some requirements. For example, minimum operator time, minimum maintenance, efficient functioning, minimum power consumption, and minimum loss of effluent quality, and a maximum integration into the environment. So the wastewater treatment technologies that can make this requirement are the extensive or non-conventional technologies. Well, now I will present in different slides the possible options, okay, for this kind of communities. In the pretreatment is the first phase of the wastewater treatment plant. The pretreatment is composed by the screening, the grid chamber, and grease chamber, okay? In the screening, we have two options. A screening with manual cleaning or with automatic cleaning. This or that will depend on the budget of the community. Then we have a static grid chamber. This is very typical in small communities. And the static grease chamber, very typical. But we have the option of combining this and this in an aerate grid grease chamber. The second stage in the wastewater treatment, the primary treatment, we have different options. For example, we have the septic tanks as a plastic unit or as a concrete unit. We have the immense tank as concrete unit or with metal sheets, or a primary settling tank. About the secondary and tertiary treatment. Well, in the small communities, I commented before that it's adequate to use the non-conventional technologies. Okay, these non-conventional technologies or extensive technology only are imitating the natural process that occurs in the environment. Okay, they are imitating the soil or the river or lakes, or the natural wetlands. For example, the green filter. The green filter is a technology that is imitating the soil. Here you can see in this picture a green filter, typical green filter, planted with populus and eucalyptus, and here an intensive green filter. The difference is only related with the distance about the trees. Well, the green filter is a plot planted with trees. We introduce the treat wastewater. It's necessary that the wastewater be treated by a secondary treatment by flooding, and the wastewater percolate through the soil. Some physico-chemical and microbiological activities are contributing to the wastewater treatment. Other technology, intermittent sound filter imitating the soil, are shallow bed, you can see at this, that present in the surface as distribution system, and on the bottom present a drainage piping to collect the treated wastewater. A pit filter. The pit filter, as they are imitating the soil. The pit filter, we have to work with different units, okay? And the pit filter present different layers. On the bottom present the pit, where is produced the wastewater treatment, and then we can use gravel, fine gravel, sand, etc. for the supporting the pit. Constructive wetland. This is a very, very common wastewater treatment in small communities in all over the world. The constructive wetland, we have different kinds, with a vertical flow, with a horizontal flow, and this is the more similar to natural wetland. This is the free flow or surface flow constructive wetland, okay? Normally we use a substrate, gravel, fine gravel, sand, etc., and we use macrophyte. The constructive wetland have several options or several uses. For example, we can use for urban industrial wastewater treatment, for restoration and recreation of water ecosystem, stabilization and deshydratation of sludge, and they present a very, very good landscape integration. Other system, I think that you know perfectly this, is the lagoon system. The lagoon system is imitating the river and the lakes process. It's composed by three kinds of ponds: anaerobic, where we reduce the total suspended solid principally; facultative, where we reduce principally the organic material, BOD, COD; and finally the maturation ponds, where we reduce principally the pathogens. And now there are two kinds of technologies that are between extensive and intensive technologies, okay, but are that have a high application in small communities. This is the tricline filter, or a percolating filter. It's only a tank where you introduce a material for the growing of the biofilm, okay? This material can be stones or other material, okay? But normally we use polypropylene. The wastewater percolates through the tank, and the biofilm is in charge of the wastewater treatment. And the other is the rotating biological contactor that is very similar to the tricline filter. The rotating biological contactor has the biofilm growing in these areas, and the process is very simple. When the biofilm is in this space, there is the oxygenation of the biofilm, and then when it's inside the tank, the biofilm is in contact with the wastewater, so there is the degradation of the wastewater. So the process is oxygenation, degradation, oxygenation, degradation. This is a very simple process. Okay, these are the different options that we can introduce in the small communities. Depending of the area, of the needs, etc., will be implemented one on other. What happened in the wastewater reclamation frame? Well, we have the treated wastewater. And now we have to think in a reclamation, in a reuse. Okay, but we have to consider that this kind of wastewater present a risk, associated principally for the presence of pathogens and other pollutants. Normally, the regulated pathogens are intestinal worms and fecal coliforms, for example, E. coli, etc. Salmonella, Legionella, well, will depend principally in the final use. So this kind of pathogens and pollutants produce a potential health risk, and depending on the higher or lower wastewater treatment and water reclamation, we can use the reclaimed water with guarantees for the health. For the wastewater reclamation, we have a lot of options, okay? We have physico-chemical options, filtration. If we have the problem of desalination, we have a lot of options. Biological treatment, okay? And in disinfection, we have a lot of options. But in small communities, they're saying that for wastewater treatment, we have to look for the money, okay? For the money, and very, very important for in the water reuse, for the to look for a safe water reuse. Okay, it's very important because the public health is very important in this sense. So the non-conventional technologies can be applied in this frame. Well, related with the different projects where in which CENTA is working related with wastewater treatment and principally water reuse, I would like to present some of them. Here you have an overview of the Experimental Center on Research, Development and Innovation that is situated in the south of Spain, in Seville. This presents 45,000 square meters destined for the wastewater treatment and reuse, principally in small communities. We have different options, different treatment, and we work principally in a frame between the laboratory and the real scale. Okay. We have pilot for a lagoon system with different modifications, different combinations of constructed wetlands is here. We have green filter, we have pit filter, bioelectrogenical constructed wetland, we have plots for water reuse, etc., etc., and we have an area destined for the testing prototype for the enterprise. An enterprise come here and test his prototype. Some projects relate with water treatment and principally reuse. For example, the use of green filters in silviculture for energy production and emerging contaminants removal for aquifer recharge. In the green filter, we are working with different kinds of substrate. So this conference has been very important for me because I have no other option for a filtrating substrate to be used in this kind of technologies. We work with the treat water in the irrigation of Jatropha curcas for biodiesel production. The treat was water in the irrigation of sunflowers for biodiesel production too. The intensive green filter for energy production, and we evaluate the soil as a reclamation treatment. The use of permeable reactive barriers were for the aquifer recharge. This barrier is composite by three materials. On the top, we introduce palygoscite, in the middle, activate carbon, and on the bottom, zeolite. But we are looking other option. The question is to look a very good filtration layer. The use of intermittent sound filters for water reclamation. This is a very good treatment to put at the end of the treatment line. And we are looking different options with the substrate thickness in order to improve the removal of E. coli. The study of nematodes, plant parasitic nematodes, as a factor for consideration in the wastewater treatment and reuse. As you know, well, people that work in the water reuse frame know that in the standard regulation or guideline regulation in all over the world for water reuse, this kind of microorganisms are not included. And this is a very a serious problem in the irrigation use, because if the wastewater present this kind of microorganisms, they affect to the plant, they affect to the crops, and this can produce a serious damage in the crops. In Andalusia, we are working in different technologies in order to perform the system or technologies for water reuse in the physicochemical and macrobiological, principally pathogens removal. In the case of the experimental center, we have been comparing the standard aeration, the pit filter, the stabilization ponds, and the different combinations of constructive wetland. Okay, this is the line. We are working with constructive wetland as a secondary treatment or constructive wetlands as a tertiary treatment. Okay, in the frame of Europe, we have collaborating in different projects. For example, this is a biosolar water recycling. It's a demonstration wastewater treatment system dedicated to wastewater reuse and recycling. This is a live project, and the wastewater treatment is based principally in the microalgae activity. In this project, for example, is include again and again in the wastewater treatment and reuse plan, the life cycle assessment is including. Okay, in this sense, we are working in the life cycle assessment in the cycle of wastewater treatment. In the cycle of wastewater treatment, we have different lines. We have the domestic wastewater treatment line, is here, and then the water reuse lines, principally the final purpose is irrigation, okay? But we have other lines, for example, related with the macroalgae biomass production, with the electricity energy production. Sorry, where is the, I don't know, here. Yes, for the fertilizer, etc., etc. In India, we are working in 4 regions in India in supporting consolidation, replication, and upscaling of sustainable wastewater treatment and reuse technologies. We are working in collaboration with Mali and Tunisia in the wastewater treatment and reuse frame. Well, with Morocco, we have a very, very large collaboration, approximately 20 years of collaboration. And here, for example, is an example of one of the project that is a cross-border campus for sustainable management of water research, where the wastewater treatment and reuse in small communities are very important. In Palestine, we work in Palestine. In Palestine, for example, we are starting work with basic sanitation, because you have to start with the basic sanitation. And then we work in the wastewater treatment and reuse. In Latin America, we work in several countries in Latin America. For example, this is some activities in El Salvador. In a cooperation frame, we work in wastewater treatment and reuse, but it's very important in the training activities. We work a lot in the training to the administration, to the technician, to the end user, etc., etc. In El Salvador, for example, we work in sanitation, wastewater treatment, and now we are working and planning project for water reuse. And as final conclusion, only 2 remarks. The limit financial and physical resource for wastewater treatment, the socioeconomic situation, and the context of urbanization affect principally to small communities, rural and low-income areas, and create the conditions for unplanned and uncontrolled wastewater reuse. And second, it is therefore that in these types of agglomeration where we have to do the bigger effort to correct deficiencies, starting on sanitation and continuing on wastewater treatment and reuse, without forgetting that there must be found options which reconcile the requirement to treat and reuse wastewater safely with sample operating techniques and operating, very, very important, and maintenance cost that might be really defensible. And thank you very much for your attention.
Any questions, please?
Thank you for your nice presentation. What I want to ask you, if you have some idea of the cost benefit for each treatment that you showed, because of course the recycling of wastewater is mainly for the poor country, because they are the country that has a problem with drought, water restriction. So of course the costs are very important in relation to the benefit.
Yes, we have analysis of the cost according to the different parameters, according to the design, according to the maintenance and operating, etc., etc. And in small communities, because this is our frame of work, the cost is very diverse, because will depend of the kind of technology that you will use. But for example, now we are working in a project in the Senegal river basin, okay? And we are considering to implement, for example, a line for domestic. If I remember, it's composite. Well, we will have to treat 50 cubic meter per day. This is the flow. And it's composite at pre-treatment, immense tank, 3 constructive wetland, and some filters. And finally, water irrigation. The approximate cost is for the construction, only for the construction, because the operating, maintenance, etc. are other costs. It's approximately 400,000 euros. 400,000 aproximadamente. No, the total construction, for example. But then you have, yes, then you have to incorporate the operation and maintenance costs, etc. But if you compare with intensive technologies that perhaps are cheaper, but then the maintenance costs are higher. So that you have to evaluate all the parameters before to implement a technology.
You can find to use, for example, a combination of filter and biofilter in combination, because we have an industry, for example, in southern Italy that produce biogas and is a product from animal farm and so on, and they are filtering the wastewater, using a combination of graves filter at different sides and cans, the biofilter, and the water that they produce is pure at 97% with low cost. So this is a kind of a combination that can be used also to find, to maintain cost. Of course, you don't have a cost of maintenance in this case.
Yes. In this area, you have a lot of combinations. Okay. You have to look only a good result, and that's your object. Okay. Yes, but there is a lot of combinations. Yes.
Sorry, you showed. I think it was a filter, a mixture of zeolite, palicoskite, active carbon, and zeolite.
Yes.
Was that were they commercial? I'm sorry to go into the economic part of it. I know in Spain we have real problem. I don't think people in Spain will realize how serious is the problem with water. I was wondering, the Paligoscite obviously is, you get it from a mine or somewhere because it's commercial, I suppose, close to where it is. The active carbon you buy it as well is commercial?
Yes, we
and
buy.
the zeolite is also
Yes, we
commercial?
buy.
Well,
This is a project,
sorry, no,
Yeah.
please.
This is a project that is developing by INDEA.
Mm-hmm.
We collaborate with INDEA Agua here in Madrid.
Yes.
And they work with different options. And when they implanted the technology in Seville, in the experimental plant, they buy the substrate.
It's because we've got some materials that are not commercial and they can compete, as far as I can understand, with the active carbon and with the zeolite. They can compete. They are not commercial and they are much cheaper. I don't know if you would may be interested in this. I would like to speak with you about that.
We are interested in all material that if this material is cheaper, better.
Sure.
Better.
Then I will get in touch with you. Thank you
And
very
now
much.
in India, they are proving other filtrating materials. Yes.